and you will have some 3 weeks to finalize it. Okay. I already posted on how to install the Sophistic, so I hope now you have all the plugins in the Revit. And I'm gonna ask you to download the seminar materials Sophistic, Sophistic 1 as its first class, and to download all these files. There's RVT, RTE, and 2 PDFs. To go through the PDFs, you have the main part 1 Sophistic tutorial, where everything goes into detail, and I'm not sure that we're gonna cover everything that is here today, because we have limited time. But we have Sophistic 1 notes, which will be quite easy for you, especially right now, today. Just to, if you miss something, you can refer to these notes and see where did you miss it. But everything more in detail and with screenshots is in this document. Okay. Some of you already saw the error when opening RVT file. And I'm gonna show you now how to detach it and how to solve it. And one thing, don't be shy to interrupt me. If you have any question, just raise your hand and ask. Okay, coming up into the Revit, you go to Models and Open. I'm going into my one folder of Sophistic, and yeah, here is the RVT file. And to not have this error, you have to detach it from the central one. So the error should disappear now. We can try it and preserve the work sets. Yep, and now you have a model. And we'll go through the steps of, for example, you get this model of architecture and you need to do now structural analysis. I will walk through all the steps of structural analysis in Revit and Sophistic environment. Okay, after opening the RVT file here, hope you don't have this error again. You also open the RTE file. Now you can just double click and it will open in another tab here. And this RTE file, this RTE file basically has standards, so depending on which company, on which project you are working, there could be different standards. So we are just presuming that this is the standard that we need. So we're going back into our RVT main project, and we go into the Manage, and there is such a button in the settings, which called Transfer Project Standards. And you basically transfer here the information that you need to take from them, from your template. And because we are doing only structural analysis, we need to check none, so we don't import anything that we don't need. And I have pasted here a list of things that you should tick and to import into your project. So it's analytical link types, color fill schemes, dimension styles, fill patterns, filters, halftone and underlay, line patterns, line styles, line weights, and line types, materials, and object styles. Reinforcement, settings, structural settings, and text types. Okay, this is the thing. Of course, you can import everything, but because we're doing structural, I'm showing you how to manage it. Okay, and we override everything, so everything which is in the standard will be here. You check none, and then choose the list in the notes. And override. Okay, now we have transferred our standard. And we're going to go into main structural analysis part. It's an Analyze Sophistic AMG. I wrote to you before that this button should appear after installing all the plugins. So if you have already your project ready, we can click on the show. And there are 3 intuitive steps to generate analytical model. What is analytical model basically is if you work before in a structural analysis software, usually you just draw your model from scratch. But here it allows us to create analytical model from, for example, architectural model, because here we have a lot of things that we don't need. For example, we don't need this renderings of the doors, we don't need the doors themselves. So analytical model basically will create a basic geometry that we will use later for our structural analysis. Okay. Yep. Yep. Did you check all these boxes? Yeah. Yeah, you go to Manage tabs. There is a transfer project standards in the settings sections. And yeah, but first of all, I said that open the RTE in your project like that. Like that. And then you go back into your project and transfer it. And then you should have it automatically here. Yeah. Yeah, this is a very minor thing to do in case you're working in a company and you need to follow an exact standard of your types, because then you can generate your structural drawings and it should be in line with the company, for example. Yeah. Did you transfer it? Okay, and now coming into our actual analytical model generator, you go into the Analyze tab in Sophistic IMG Analytic Model Generator and the Show tab. You will get this additional tab that will help us to generate our analytical model, and there are intuitive steps. And let's go from the first one as prepare. And it's showing us which element it will transfer into the structural, because as I said, we don't need all this extra information on the furniture, on the doors. We will just use our load-bearing elements for structural model. And you can also configure your elements that, for example, it will read beams if it's minimum length of 30 centimeters, or the column should be minimum 30 centimeters. So you can all configure here. For now, we won't be configuring anything, so we won't have time. But in case you have a special project that there are very small or big beams, please configure them here. But now we can just work in the default mode. And yeah, now we have elements and we run the prepare. Yeah, and because we have here the visualization of disabled elements, we see that modeled this pin foundation is not counted in our structural model. And this is fine by me, for example. But in case if you want to use this foundation, you can just click on the element and enable it. I won't be doing it because I will show you another way how to analyze and how to design the foundation. But for this model, I don't need it. But if you have that something that you need is disabled here, it will be highlighted so you can see what you need. Okay, now let's go to generate. After we prepared our model, we open the generation and we choose analytical mode here. Okay. for now, this shows the elements that we're gonna use for our analytical model. And we run it to generate our analytical model. Yeah. And now we have our analytical model that will be later transferred into Sophistic. We can see here, again, by clicking, for example, there is the analytical panel, there is analytical member, which is a column, and yeah, there are a lot of different elements that we can click on. Did you manage to get to this point? Problems? Generation or, okay, yeah. It's a bit trickier for me, but I will show you the step. Firstly, you prepare the model, open and run this one. I'm not going to do it because it will do double analytical model for me, but yeah, I'll just talk you through. You go to prepare, you run to see the disabled elements. Then you just go to generate, you choose analytical mode and run it. Yeah, so you will generate the analytical models that you will use later. Okay. And we can also check it. Because the problem with analytical model and with this two environments of Revit and Sophistic, that sometimes the members are very complex, and sometimes the analytical model can be generated wrongly. So usually we run checks, coordination and analytical quality checks. So you just basically tick both and you run it. Yeah, and it shows that we don't have any problems. Because sometimes it can happen that it won't be aligned, some of them, when you will be designing it, or if you have a very big project, some of the members can be flying around, so you can check here. But because we have a simple model, we just have 25 elements, so it's quite easy. And important to note that, for example, if sometimes the model can be generated like that, and it will give you the check. So you can just go and manually fix it in case you have this problem. But this model that I gave you is pretty clean, so we won't be stuck here. So yeah, you can, but in case you get the analytical model which is false, you can generate, you can adapt it here. And the same goes for the panels. You can adjust here the panels. Yeah, it should say that it's not planar now. Yeah, but basically if you have this problem, you can just adjust it, so it's not a problem here. Yeah. Yeah. No, firstly you prepare, and you click on the element, and there is such a, here's enable. You just untick it if you don't want it. And the same goes if you want it, you just click on it and enable. Yeah, yeah. To choose the element that you want, and then you generate it. Yeah. Before, in the previous versions, there were no such steps. There was only generate, but now we have this in the 2023. Okay. Yeah, and the thing is that now, after we generated the model, if we close it, it will basically disappear. And I'll show you how to create a model. Of course, you can do it also here. Just after you run it, there is such a button to create a view. But we gonna have a specific view. You go to the 3D Ansicht, 3D view, and you duplicate it. Duplicate the view, and you call it 3D Analytical, for example. And yeah, now we can close the Sophistic thing. Okay, but the analytical model is here preserved, we just don't see it. And now we would like to see it. And after duplicating the view, which now we'll see the analytical one, we go into the view and visibility and graphics, or you just click VG on your keyboard. Okay. And here, because we only need this 3D analytical model, we don't need to have all this architectural piping and other things. We just click all, here, and also we untick everything because we don't need other things here. But the only thing that we want to have here is view tab, graphics sections, visibility and graphics. Okay, and here we untick everything. Yes. Okay, we untick it. I just press Ctrl and choose everything except SOP load divisor, and we untick it. So we have to untick everything except the SOP load divisor. Yeah. Okay. And after having this on, we go to analytical model categories, which actually we need. Yeah. Yeah. Okay. Yeah. We duplicate the view first, and we choose the analytical 3D view, which we want to use for structural analysis. We go in here, because we want to preserve here our original view in the original, but we created this one just for us. And we go into the View tab, into the Graphics section, and Visibility and Graphics button here. And we can click here All, and just untick it. But now, because we need the analytical and we need this SOP load divisor, because this is specifically for Sophistic, we go into the lines here. We tick the lines, and we choose everything with Ctrl pressed, except SOP load divisor again. So now we have everything unticked, except SOF load divisor. It will show up later when you'll be doing the loads. This is a special Sophistic one, so it will be imported correctly and you can see what it is. Because if you will untick everything and you will create a load, it will import into Sophistic wrongly, so you have to tick it to see it, and so it will import correctly later in our Sophistic environment. Okay, and after we go into the analytical model categories, and here we need everything, because this is an analytical model and we want to see everything. Just to catch up, in the model categories, everything is unticked except SOF load divisor, which is hidden under the lines, and analytical model categories should be all on. Okay, and then we click OK, and we get this analytical view, which is basically the geometry that we need for using in our structural analysis. And now you can really see that it looks like a typical structural analysis software. Okay, did you manage to reach here? Because now we'll go into more structural analysis things, and we're gonna go into the analyze, and we will create boundary conditions and loads. Here you have nodes, you have lines, you have panels, so everything that we need for a structural model. And going into the boundary conditions, because we have to give some kind of foundation to this model. Analyze, structural analytical model, and boundary condition button. And you get this new tab where you have the boundary condition, point, line, and area, and now it goes more like intuitive if you worked before in the structural analysis software. You will need different depending on your models. For example, as I said before, I did not take into account that pinpoint foundation because, for example, I want to design it in another software and I just need forces from the big model. So here I can simplify and put just a point load here that it's gonna be, and here's a state is fixed. At least this is what I need for me. But in case you have beams on the roof, it can be pinned, or you have a different type of foundation, you can choose here whatever you want. If you want to have, if you have specific stiffness to your foundation, you can choose user and put it. And now I press escape and click on it. Okay. Yeah. Now in the properties, you can see the difference. This one has stayed fixed, and because all the translation and rotation is fixed here. But if you go to the user here, you can actually give different value to your translation and rotation, to your degree of freedoms. For example, I want to have a spring, and you give the modulus. But for simplicity reasons, we're not going to have it today. We're just going to make all them fixed. Okay, let's go again. Yeah, I'll put the point fixed into this columns, under this columns. Yeah. I hope it's clear that you can give another state, different states for your boundary conditions. And another thing, you have also lines and areas, and area boundary conditions. It depends on, again, on your model, how it is going to be supported. I'm not going to use it here today, but for example, as I used previously in the project, I used area boundary condition, for example, on the slab, for example, to show that it's supported by the earth. But we're not going to do it today. Just keep it simple. Yeah, but so you know that there are 3 different types of boundary conditions. Yeah. Another thing to show you. Here. Let's go to the statistic analysis, to user interface and structural properties. And when you click here, you get another sophistic tab here, a new one. And when you will be clicking on your analytical model, here you can check how your sophistic layer will read your elements. For example, this beam will be read as column, and its section is centered. You can also give groups to your elements, so it will be easier for you then in the analysis to modify them. For example, you can give all the columns that are located on the ground floor a group 0, for example. Yeah, it's already applied. But yeah, this is just an extra step that if you would like to be more consistent and more structured with your model, you can place it here. You can also check, for example, the release bottoms. Yeah, there are a lot of possibilities that you can check if you are working as a civil engineer and you want to perform a structural analysis later. You can define all these things here. For example, the thickness as well. Yeah. After defining boundary condition, important thing for us is loads. Yeah. But first of all, let's go into the manage, and you go into the manage tab, settings and structural settings here. Why we are going here? Because for loads, we need to define the natures and the load combinations. And we can do it in Revit. And now we have everything here, but if you are going to do it from the scratch, again, you click on the load nature, you can create any nature that you would like to, because in the beginning there is nothing, and you should write your natures yourself, like a wind, snow, temperature, and anything else. Yeah, we have 2 snows, for example. Settings here. Yeah. You can see. And the load cases as well. For example, yeah, there is like a self-load, and there is a dead load. There are different winds, because for structural analysis, as we know, we need to have winds from different directions. So you define it here, as well as earth pressure and other different things. Yeah. Yeah, but we can define it here. You can define it manually, but I will show you a way to do it automatically. It will be done later in the sophistic. It will be in the second part, the next week. But if you would like to have, for example, manually, you can create it here. You can just add it. You don't have to do it. I'll just show you that, for example, this formula, I choose the factor for this combination will be 1. And yeah, there are just, and it adds up. I think it's quite intuitive, but we're not going to do it because we can do it automatically. So we don't have to do it now. Yeah, let's just delete it. But what I wanted to mention is that the natures and cases should be defined here. So it will be rightly important later, and we can define them as well. Okay, I showed you where the load natures and load cases, because now we are going to go and define our loads. We go into the analyze again, and where we had our boundary conditions, we have as loads as well. And when we go to loads, we have this 6 buttons, 6 different types. Again, point, line, area, and there are also hosted ones as well. Hosted means that it will basically move when you will move an element, so it will go with your element aligned. But if you just put an area load and then move the element, the area load will remain on that place. So depending on what you prefer, you can use different ones. But yeah, for example, let's make a line load on the beam here. For example, let's define a wind on this column. Yeah, we just create, yeah. Let's work firstly from the hosted, because it's quite easy. You just choose an element that you would like, that would host this line load that you're gonna put. For example, let's put wind plus X. No, just choose a load, and now you can define the load case. And here you can actually see all the load natures that I showed you before. That there is earth pressure, there is a wind, so it depends on what you need. You put it here. And then there's orientation, and again, if you are familiar with the structural analysis softwares, you can orient it usually according to project, XYZ coordinates, or according to your element locally. For now, I'm choosing it as project. It will be a uniform load, and here you can modify any values that you would like. And after putting it here, I just choose an element. It also means that you can modify it later. For example, escape, you put it here, and then you realize that you don't want it in this direction. So you just put FY2 and you put 0, for example, and it will change the direction. So it's quite easy. And now it will be hosted to this beam element, to this column, so it will be going with it if you will be moving it. Yeah. And the same goes for other things, like let's check hosted area load. Let's create a snow on this floor, on the upper floor. And yeah, it's, for example, already automatically gives us some values. But yeah, let's just play around. And we just choose the panel that we would like to host it. And yeah, be aware of the signs. Usually it goes for me it goes as trial and error personally, that I just put it and I see in my view, is it going downwards or upwards? So I can modify it, but usually Z is always down, is minus. And X and Y can be sometimes a bit more trickier. Yeah. So yeah, now we have a snow load here. And you can of course modify it later now, that here is a wind, here is a snow. again, I'm not gonna go through all the steps. Yeah. And yeah, what we're going to do now also is try another load. But now let's choose another. Let's make an earth pressure. And you know, earth pressure is usually variable. And if we're gonna choose not hosted, a general one, you can see that now I cannot touch it. For some reason, only this lights up. And as you know from the, I hope you remember from the Revit classes, you need to define a work plane for your load. And yeah, after choosing it, you have this create area load boundary. And you need to set the work plane that you're gonna work in. And okay, maybe, yeah, I should repeat the step, yeah. Okay. You go into the analyze loads, and now we're gonna try not hosted, but the area load itself. For example, you want it partially, not on the whole floor, but for example, I want only on this half of the building. But yeah, doesn't matter. Let's try the area. Let's set the work plane, because now, for example, I cannot draw on this side, and I want to draw on this panel, and I cannot. So you have to set the work plane. And there are two different ways to set it. You can set it according to grid. Again, as from the Revit file, you remember that there are grids that you define, and for example, if I choose the grid 1, let's try it. Yeah, now it shows up as this one, so you can work only in this dimension of the, in this plane of the project. But I want from this one, I don't really know, but yeah, let's check the grid A. Yeah, this is this side. So we're gonna work on this work plane. There are different ways to define it as well. I want to use it as a rectangle, for example. Yeah, and I just draw it. Again, if I want it half, I can do it half. So this is an advantageous way to use just a free general area load, not the hosted. Yeah, but I will just define it like that. And it will be an earth pressure. And it's not for sure gonna be 0. Yeah, let's put it X. I don't know, just out of my mind. Okay. Okay. Yeah, and now we see that it's in the wrong side. This can happen. Oh, just a second. I'm giving away everything. Yeah. Yeah. But of course, you can define everything as you want. Here again, it's clear. Yeah, yeah, this is that. This happens because we are orienting it to work plane. We can orient it to project. It will be here. So now you can see the difference between the work plane and the project. Yeah, because this is the Z dimension of our work plane. But in the project, as you remember, Z is a vertical one. So if we'll put the project and Z, it's going to be in this coordinate. So yeah, it depends on you which coordinate you would like to use. For example, here. Here, orient to, in the properties, there is a work plane and project. So check which orientation you're using. Is it project, the global one, or the local work plane? And yeah, I want to define an earth pressure, but it's from the inside, so it's illogical. So I put it to minus here. Yeah, so this is the right. But again, as I said to you before, the earth pressure should be variable. 0 on the 0 height. And another important thing now, after we created the area load, we want to make it variable. We go into the, again, we click on our area load, go into the edit boundary, and there's such a tool as a reference point. This we need for referencing, again, that we want to show it, like you work with the topography the similar way, you define a point that you would like to have a different value. Because it's -2 and I want it to be on the bottom, I will add another point on top here. I will click on it. Let's go again. Yeah, you choose any area load that you would like to modify. You click the edit boundary, and there's a tool of reference point. And you define 2 points that you would like to have different values. For example, this one and this one. And now you can see that there is such a small number, 1 and 2 down here. And I click only the 2 because there are 2 different values. And here you can define the forces that will be different. And right now, for example, I'm realizing that I choose 1 point and it's -2. And for example, if I will leave everything like that, we'll see this. And yeah, this is the problem, and we can define it here, that again, the upper part will be 0, and the down part will be -2, for example. And edit mode. So it's all very editable and intuitive. You can just click it and modify as you would like to. Yeah. And here you can see the statistic load divisor, by the way, that yeah, this is our load, which later will be important as a statistic as pressure and load. Do you have any problems till this point? Or questions? Yeah. It's applied on the whole circle, because when we edit boundary, here in the pink you can see the whole area that it's applied to. But if you'd like to have only only line, for example, you can define only line. Then it will be only in one line. So yeah, this is it. Maybe let's have a 7-minute break till 15 minutes, and then we'll continue. Till 12:15.